All right, so now we have our first interactive notebook here. So this opening page tells you, obviously this is Math 1. We are in Module 1. That module is called Expressions. This is all on the front page. You notice there's a place for your name and period. I need your first and last names on that line. Remember, you do turn this notebook in for points. So make sure we have put a first and a last name on the line. Obviously, I'm going to put my name. So again, your first and last name. And now we're in second period, so we should be putting the period number on there. That should always be the first thing that we do when we get our packet. If you open up the notebook on the back side of that first page, I have put 2 bell schedules. They're the 2 most used bell schedules. The first one being our regular bell schedule, which we are on today. And the second one being our late start bell schedule, which is the one we were on yesterday. I always just throw those in there so it's another place that you can look. Do we have other bell schedules? Absolutely. On Friday, we're going to be on a double assembly schedule. But we only do that once or twice a year, so I don't bother with printing that out. All right, the next page, table of contents, tells you what's in this notebook. Today we are going to get started on that first one, numerical expression. So what we should be doing is every time we start a new lesson, putting the date in which we started. So today is August 20th, so there we're going to write in 8/20. Again, this is part of being organized and knowing when did we do which set of notes. And you'll also notice on that page it says essential question or questions. Each unit we will have some questions that you should be able to answer by the end of the unit in your own words. So we're going to write those down today so you know what they are. We have a few more this unit because it's review, and these are things I think you should already know for the most part. So our first question: what is a numerical expression? Question 2, what are the order of operations? Question 3, what words or phrases indicate which mathematical operation to use? What words or phrases indicate which mathematical operation to use. Number 4, what is the distributive property? And the last one, what is absolute value? So again, these are questions that by the end of this unit, in your own words, you should be able to answer. And as we move on in the packet, if you turn the page behind that, we have what's the assignment log. I told you earlier this week, one of my focuses with you is to help you work on organization. So part of that is making sure you are writing down what is your homework, when is it due. And these are actually just for the worksheets. Could there be other assignments? Yes. But this is if I hand you a worksheet, when I hand it to you, I'll tell you when it is going to be due. Besides, I also write it on the calendar in the front. It goes on Google Classroom. But this is part of you staying organized and writing it in here. And when I go to grade your interactive notebook, this is a part of that grade. If you do not fill out your assignment log, you lose points. This is part of making sure we are taking care of everything. Obviously, we don't have anything to write in there yet because we haven't had an assignment yet. We keep going to the next page. Now you have 2 pages of warm-ups. Tomorrow you'll probably have a warm-up when you come in. It'll already be written up there. I expect you to get out your packet, write it down, and get going. We don't have one today, so we're going to go past our warm-ups. And we may not use all 8, especially this unit. It's a little shorter, so I don't know that we'll get all 8 in, which now takes us to page 7, where we're going to get started on those notes for 1-1 numerical expressions. All right, so it defines what a numerical expression is for us right there. A mathematical phrase that contains only numbers and mathematical operations. So it's really when we're talking about math and we say the problem out loud, that is a verbal description of what the math is going to entail. So the first example here says write a numerical expression for each verbal expression. So the first one they give us 1 plus 8 divided by 3. So it's really just breaking that down. We have the 1. So we put the number 1 in place of the word 1. Then we have the word plus. which is telling me, okay, I need to add. Then I have the number 8, 1 plus 8. Divided by, now this is a phrase, so both words are going to indicate the mathematical operation. Now, I am drawing in the division symbol here. A lot of times, though, when we get to problems, that is not how we'll write division, and we'll see that in an example in just a moment. But for this one being a very basic, and then we have the 3. So there is the numerical expression that matches the verbal expression. We're just matching the math to what is being said. All right, the next one is not all written out in one line, which makes it a little tougher. All right, so the first thing we have here is 7. So we're going to replace that with the number 7. And I'll color code mine so you can see where I'm getting the different information. Then it says times. Now, I am going to use a dot. I am not going to use an X because we're already in the point where we're using variables in math, and X is a very common variable that we use in math. So we don't want to use that for multiplication. We want to make sure there is other ways we can show multiplication, and we will talk about that today. Then we have 15 minus 2 times again 9. So again, it's just a matter of taking each of those descriptions and writing out the math, either the number or the operation that matches. Now, the difference between these first 2 examples and the next 2 is the next 2 are going to include grouping symbols, which means there's some math that has to be done before other math can be done. So that is going to be, here we are going to have some grouping symbols. Because we see a phrase, the sum of, or the difference of, that's telling us that that has to happen before some other math. We can't just put it in order without grouping symbols. So we have the sum of 5 and 9. So I'm going to put that in parentheses, 5 plus 9. I have to do that first. So there is the sum of 5 plus 9. And then I have divided by. So I am going to use my division symbol here, and then I'm going to rewrite it. We're going to say, how else can we write this same phrase? without using that division symbol, and then by 2. Now again, as we get more advanced in our math, we aren't using that division symbol anymore. If I want to do 5 plus 9 before I divide by 2, that ends up going into my numerator, and then I use a fraction bar to show division. So what I have written on the left is correct. It does match the verbal description, but how we would see it more commonly written is the 5 plus 9 would be on the top, the 2 would be on the bottom, because we have to add before we do that division. All right, number 4, the difference of 12 and 9. So we already know the difference of is telling us we're going to have some grouping symbols. So we have 12 and 9 that we need to have the difference. So parentheses 12 minus 9. Times, I am going to start out using the dot for multiplication here. And then 4. But again, as we move on and get more advanced with our math, just like we don't use the X in multiplication, a lot of times we don't use the dot anymore. Another way we could write this would be parentheses 12 minus 9 parentheses 4. When you have two sets of parentheses next to each other, that's indicating multiplication. If there is no operation symbol between the parentheses, that is telling us that we should be multiplying. So again, it's just a way of understanding what are we being asked to do, being able to translate and understand those words versus what the math looks like. All right, the next example. Now they're giving us a full description of things happening. And they're going to want us to write a numerical expression from this description. So it says a person's handicap in bowling is usually found by subtracting the person's average from 200, multiplying by 2, and dividing by 3. Marley's bowling average is 170. Write a numerical expression for Marley's handicap in bowling. So let's break this down to the parts. First says subtracting the person's average from 200. So we have 200 minus the average. Then it says multiplying by 2. So that 200 minus the average goes with the yellow. So now I'm going to take that and multiply it by 2. So now I have 2 parentheses 200 minus the average. And then it says dividing by 3. So now I take that previous line and divide by 3. Then they go on to tell me, well, Marley's average is 170. So I can substitute that 170 in. So the handicap equals, instead of that abbreviation average AVG, I'm going to put in her 170. So I'm going to have 2 parentheses 200 minus 170 parentheses, and that's all going to be divided by 3. Now, they didn't ask me to simplify that and find out what her average actually is. That is simply the expression that would be used to calculate her average. Now, there are some problems coming up where they are going to ask us to actually calculate. But just for this, for the expression, that's all we need. All right, the next one. To convert a temperature in degrees Celsius to degrees Fahrenheit, multiply the temperature in degrees Celsius by 9, divide by 5, and add 32. So again, if we break this down to the parts, multiply the temperature in degrees Celsius by 9. So again, I'm going to start this off to the side. So we're going to have 9 parentheses, and whatever that Celsius temperature is, that is 9 times the degrees Celsius. Then it says divide by 5. So now I have 9 Celsius. Divide that by 5. And then the last part tells me to add 32 to that. So now I have 9 Celsius divided by 5 plus 32. So now I've built the expression that matches, but it says write a numerical expression for the conversion of 37 degrees Celsius to Fahrenheit. So where I have that word Celsius, I'm going to replace that with the 37. So the conversion equals 9 parentheses 37 divided by 5 plus 32. Again, they did not ask me to simplify that, so I don't have to do anything more with that. I've simply written the expression that we would be able to use to convert Celsius to Fahrenheit. All right, and then you notice the next thing on the page talks about order of operations. Now, I know you've heard of order of operations before, but what do we usually talk about when we talk about order of operations? PEMDAS. PEMDAS has been taught for a very long time. I'll tell you, PEMDAS was taught when I was a child, so you know it's been taught for a very, very long time if I was taught that. PEMDAS is fine, but PEMDAS has some flaws, which is why you notice I don't have PEMDAS written on here. But let's talk about, what does PEMDAS stand for? What does the P stand for? Parentheses, the E, exponents, the M, multiplication, the D, division, the A, adding, and the S, subtracting. All right, but what is the flaw? Does anybody know what the flaw in PEMDAS is? If we simply just go by those letters, Does anybody know where the flaw is in PEMDAS? Yes, sir. Exactly. It makes you think that multiplication has more power than division, and the same thing happens with addition and subtraction. If we simply go by PEMDAS, we put the M before the D, so people think, well, that means I have to multiply before I divide, and we put the addition before the subtraction, so I need to add before I subtract. And this is the one flaw in well, actually, there's another flaw in PEMDAS that we'll talk about in a minute. But if we don't know, multiplication and division are what we call inverse operations. In other words, they can undo each other. So really, they're kind of like brother and sister. They're together. They're the same family. Addition and subtraction are the same way. They are also referred to as inverse operations, which means that they can undo each other. So one does not have more power than the other. So while PEMDAS is a great mnemonic device, and a mnemonic device is a memory device to help us remember the order, if we don't teach you that about those inverse operations and make sure that we are making it very clear, we end up making mistakes in how we do our calculations. So we're going to write out the steps a little differently, and we're going to talk about one more flaw that happens in PEMDAS. So our first step is going to say evaluate expressions inside grouping symbols. Evaluate expressions inside grouping symbols. Now, our PEMDAS started with just P. We said parentheses, but that is not the only type of grouping symbol. Now, is it the most common type of grouping symbol we see in math? Absolutely. But when we're talking grouping symbols there, it is not just parentheses. And that's where that also leads. So parentheses are a grouping symbol. Can anyone name another type of grouping symbol? Brackets. I was showing you squaring off because parentheses are rounded. Brackets are squared off on the top and bottom. I was trying to visually give you a little clue on what I was looking for there. So by saying just parentheses, we aren't being completely honest about everything we're talking about. That's why now we're talking grouping symbols, parentheses and brackets. Step 2, evaluate all powers. And in parentheses here, I'm going to put exponents because that's what we are talking about. That's the only part of PEMDAS that really does talk about what it means and what we need to evaluate. And then step 3, this is where we're going to put those inverse operations on the same line. So step 3, we're going to say multiply and or divide from left to right. Multiply and or divide from left to right. So now we're showing that one does not have more power than the other. As we evaluate an expression and we read a mathematical expression like we read a book from left to right, I read and see, do I come to multiplication or division first? Whichever one I come to first, that's the operation I'm going to perform. Again, it doesn't have to be multiply and then divide. I could have division first and then multiplication. So we need to make sure. And then step 4 again is going to bring in the other inverse operations. We're going to add and or subtract from left to right. So this is a much clearer description of our order of operations. Is it nice to know PEMDAS? Yes, because at least it gets us knowing what operations we're talking about, but we need to understand the breakdowns of those operations and what it truly means and how we need to apply it. All right, so if we go on to the next page here, it says evaluate each expression. So we need to understand what 2 to the 4th power is asking us. And remember, the exponent is telling us how many times am I going to multiply 2 times itself. In this case, there's a 4. So 2 to the 4th power is really saying 2 times 2 times 2 times 2. I'm going to multiply 2 times itself 4 times. So when I take the first 2 times 2, I get 4, and then I have times 2 times 2. And then 4 times 2 is 8 times 2, which leaves me with a value of 16. But it's understanding how do we use that power? How do we calculate that? Now, could you put that into a calculator? Absolutely. But I just want to make us get us thinking about what does the math mean. If we put it into a calculator and we don't understand what it means, it doesn't help us out. Number 8, 4 to the 5th power, which means we're going to take 4 times 4 times 4 times 4 times 4. So I should have 5 4s listed out there if I've done it correctly. So I take the first 4 times 4, which is 16. And then I still have 3 more 4s. And then I take 16 times 4, which gives me 64. With 2 more 4s. 64 times 4 is 256. And I still need to multiply that times 4 to get 1024. So again, I need to understand what is the exponent telling me? What math are they asking me to do at this point?